Good morning everyone. Myself Sandhya, I am from ECE department. So today I am going to give a third lecture in electronic measurements and instrumentation. So before going to the today's topic, let us revise the last unit topics. So in the last unit topic we have discussed different static characteristics of an instrument. So the static characteristic determines the performance of the instrument. So in order to know the performance of an instrument, we need to know its static characteristics and also the dynamic characteristics. So in the last class we have discussed about the static characteristics. So the six static characteristics are accuracy, precision, next resolution, expected value, error, and also the sensitivity. So in the today's class, before going to the dynamic characteristics of instruments, let us have the errors in measurement and also the types of errors in this instrumentation process. So let me write it in a short note. So the today's topics are error in measurement, and also the types of errors. So these are the things we need to cover in the today's class. So the first one is error in the measurement. So today's topic is error in the measurement. So in this error in the measurement, first of all, what is a measurement? So this measurement is the process of determining the unknown quantity. So we have to determine the unknown quantity which is compared to a standard value. This is called as a measurement. So in this measurement process we have the expected value and also the measured value. So first of all, what is error in the measurement? So error in the measurement means the degree up to which the measured value reaches to the expected value is called error in the measurement. So it is the error in measurement is the degree up to which the measured value reaches to the expected value. Measured value reaches to expected value. So this is the error in the measurement. So this degree up to which the measured value reaches to the expected value can be of two different types. It may be an absolute error or the relative error. So it may be considered as the absolute error or percentage of errors. So we have to define this absolute error and also we have formulas for this absolute error. So let us have the formulas of this absolute error and we will solve one problem regarding these errors. So absolute error. So this absolute error is same as the static error. So absolute error means the difference between the measured value and the true value. So this true value is also called as an expected value. So the difference between the measured value and the true value is called as the absolute error. So it is the difference between expected value and the measured value. So let us consider this absolute error be small e. So small e is the absolute error. The absolute error equals to difference of the expected value and also the measured value. So let us assume the expected value to be yn. So this is the expected value and this is the measured Next, yn is the expected value. Next, xn is the measured value. So here I have defined the absolute error, which means the difference of the expected value and the measured value. So which is represented as small e. Small e equals to yn minus xn, where yn is the expected value and xn is the measured value. So this measured value xn may be higher than yn or it may be less than yn according to the instrument. So in order to solve this problem, we are going for the modulus. So now the percentage of error equals to yn minus xn by yn into 100 percentage. So the percentage of error equals to yn minus xn by yn into 100 percentage. So yn is the expected value and xn is the measured value. So here I am keeping the modulus symbol because the value may be greater than yn or less than yn. So in order to remove this negative sign, I am indicating it in a modulus form. So which is equals to yn minus xn by yn into 100 percentage. Next we are going to define about the relative accuracy. So this relative accuracy can be denoted as capital A, whereas relative accuracy is the difference between the measured value and the true value. So the relative accuracy A equals to 1 minus yn minus xn by yn. So this is the formula for the relative accuracy. So from this we can determine the percentage of accuracy. So the percentage of accuracy small a equals to capital A into 100 percentage. So this is the formula for the percentage of accuracy. So here we have defined the absolute error and also the percentage of error and also the relative accuracy and the percentage of accuracy. So the formula for the absolute error is equals to yn minus xn, and for the percentage of error is yn minus xn by yn into 100 percentage, and the relative accuracy A equals to 1 minus yn minus xn by yn, and the percentage of accuracy is A into 100 percentage. So these are the formulas. So based upon these formulas we can solve any problem. So let us solve a simple problem for calculating this accuracy and percentage of accuracy and also error and the percentage of the error. Now let us take an example. So in this example we are going to measure the percentage of error and also the relative accuracy. So the problem is, if the measured value of voltage in a particular circuit is given as, so the measured value in a particular circuit is given as 80 volts. Suppose this is the measured value. Suppose if the measured value and expected value are given, so how are we going to calculate? So if the expected value is 80 volts and if the measured value means the value which we get with the help of the instrument. Measured value is 79%. Then calculate first we are going to calculate the accuracy, error which may be static error or absolute error. Calculate absolute error, percentage of error. Next, absolute error equals to yn minus xn. So here yn is given as, yn is the expected value which is given as 80 volts. Next xn which is given as 79 volts. So the percentage, so the absolute error equals to 1 volt. Next. Next we need to calculate the percentage of error. So with the help of percentage of error, so percentage of error equals to yn minus xn means 1 volt. So yn minus xn means yn is 80 minus 79 divided by 80 into 100 percentage. So this is equals to 80 minus 79 1 by 80 into 100 percentage, which is equals to 1.25 percentage. So the percentage of error equals to 1.25 percentage. So keep every answer in a box. Next, so we have, so two things we have calculated. Next we have to calculate the relative accuracy and the percentage of accuracy. So now the relative accuracy A equals to relative accuracy equals to, the formula is yn minus xn by yn 1 minus yn minus xn by yn. So we have to subtract yn minus xn by yn from 1. So which is equals to 1 minus yn minus xn means 80 minus 79 by 80, which is equals to 1 minus 1 by 80, which is equals to 80 minus 1, 79 by 80. So if we calculate this, we will get 0.9875. So this is the value of relative accuracy. So the relative accuracy equals to 0.9875. Next, we have the last one, which is, so from this relative accuracy we are going to calculate the percentage of accuracy. So the formula for the percentage of accuracy is A into 100 percentage, which means relative accuracy into 100 percentage. So the percentage of accuracy calculation. So the percentage of accuracy equals to A is 100 percentage. So here A is the relative accuracy. So the last calculation. So A we have that is 0.9875 from the previous calculations. We are getting the relative accuracy. So 0.9875 into 100 percentage, which is equals to 98.75 percentage. So this is the percentage of accuracy value which we have got from the given values. So like this, if the expected value or the measured value is given, we can calculate the relative accuracy, percentage of accuracy, and also the corresponding errors and the percentage of the errors. So far we have calculated the errors in the measurement. So the errors in the measurements are absolute errors or percentage of errors. So depending upon these errors, we are going to Next, second one is the systematic errors. Systematic errors. Next, third one is random errors. So, systematic errors are of three types. First one is environmental errors. Next, second one is observation errors. And next one is instrumental errors. So the three types of errors are gross errors, systematic errors and random errors. So in systematic errors we have three errors. Those are environmental errors, instrumental errors and also the observation errors. So let us look into these errors one by one. So first one is the gross errors. So how we are getting these gross errors while taking the measurements in a particular instrument. So these gross errors are the errors which were caused due to mistakes which were done by the human beings. So these are the errors which were occur due to the mistakes done by human beings. So the mistakes done by the human beings can be considered. So further, if you consider these human being mistakes, then we will get the gross errors. So the causes may be like this. So the first cause may be, so the causes of gross error. So the first one is improper usage of the instrument. Improper usage of the instrument. Next, the second one is if the person takes the wrong readings. So, wrongly taken readings. Wrong readings taken by a person. Taken by a person. Next, if a person has an insufficient knowledge, then it is also a cause of a gross error. Insufficient knowledge. And the last one, fourth one is if he has an insufficient knowledge, then he will be unable to do the correct calculations. Then there will be changes in the results. So the wrong calculations in the results. So the wrong calculations in the result. So these are the four main causes of the gross errors. So first of all, gross error means the errors which were caused by the human beings. So the four types of causes of these errors are, first one is if there is an improper usage of the instrument, or if he takes the readings wrongly in the instrument, or else if he has an insufficient knowledge, then he will do the calculations wrongly. So these are the mistakes of the mistakes. So due to these mistakes, we are getting an error. So that error is called as a gross error. So these gross errors cannot be completely eliminated, but they can be minimized by following certain rules. So the rules followed by us in order to eliminate these gross errors are as follows. So these gross errors cannot be eliminated, but they can be minimized. then only we will reduce the error. So the methods for reducing gross error. So those methods are, the first one is the taking more than 1, which means taking at least 3 readings. At least 3 readings for any measurement. Next, the second one is some are taking the readings before setting. So first of all, before going to take the measured values, we have to set the instrument to 0 value. Then only we have to take the reading. So second one is set the instrument value. Set the measurement value initially to 0. Measurement value initially to 0 before starting the measurement process. So by using these two methods, we can reduce this gross error. Next one is the systematic error. So the second one, which is the systematic error. So these systematic errors may occur due to shortcomings of the instrument, which may be due to aging of the instrument, or it may be due to defective parts of the instrument or worn out parts of the instrument. So let me write this. So due to aging of the instrument, means the instrument is old, then we have to get the wrong readings. So aging of the instrument. Next, second one is the due to defective parts in the instrument. Defective parts in the instruments. Next, third one is due to worn out parts in the instrument. Worn out parts in the instrument. So these systematic errors can also be caused due to the mechanical structure and the non-linear characteristics of the components which we use in the instrument. So the main cause of the systematic error is due to mechanical components used in the system, due to mechanical components, and also the non-linear characteristics. So there is no problem with the linear characteristics, but if there are non-linear characteristics, so the components having the non-linear characteristics can occur the systematic error. So the 5 different causes of the systematic error are aging of the instrument, defective parts of the instrument, worn out of the instrument, and also the non-linear characteristics, and also the mechanical structure of the components which were present in the instrument. So let me explain the systematic error with the help of an example. Suppose if we take a de-orthogonal movement. So the example for the systematic error is de-orthogonal movement. De-orthogonal. So de-orthogonal movement is a mechanical instrument which is used to measure the current and also the voltage. So with the help of this instrument we can not only measure the current but also the voltage. So the principle behind this de-orthogonal movement is it consists of the permanent magnet and also the current carrying coil which is present near to this magnet. So the current carrying coil will exert a magnetic field which which is present by the magnet, and it moves according to the force. So it exerts, so the current carrying coil exerts a force due to the magnetic field. It exerts, not only exerts force, and also it moves to some way. So the amount of the current flowing through the coil will be proportional to the force exerted by the coil. So this is the principle behind this reversal movement. So if we take this reversal movement, so what are the systematic errors which occur in the reversal movement? In this, the first one is due to irregular tension in the spring. Irregular tension in the spring. So if a load is attached to the spring, then it consists of then it produces an irregular tension in the spring. So which may be a cause of this systematic error. And the second one is stretching of the spring. Stretching of the spring. Next, the third one is friction, which is caused by the bearings in the components. So the friction which is caused by the bearings. Next, the fourth one is overloading of the instrument. So these are the four causes of a mechanical instrument. So if you consider a mechanical instrument, that is a reversal movement. So the reversal movement is used to measure the current and also the voltage. So if you consider that a device or an instrument, so the causes, so there are four different causes which causes the systematic error. The first one is the irregular tension in the spring, which is caused when heavy load is attached to the spring, then it causes the irregular tension in the spring. Next, second one is the stretching of the spring. Next, third one is the friction, which is caused by the bearings. So generally bearings are used to reduce the friction between the two metals. So if we are using the same bearings, and if the time, according to the time, then the friction will be caused due to inability of these bearings which we are using. Next, the last one is the overloading of the instrument. It can also be one of the reasons for causing the systematic error. So in order to reduce the systematic error, what we have to do? So the steps or the methods for reducing the systematic error are: first one is steps to reduce systematic error. So the first one is, first we have to select a proper instrument. So proper instrument is selected for the proper application. Selected for the application. Next, the second one is we have to add some correction factors depending upon the instrument error. So we have to predetermine the instrumentation error and we have to add some correction errors if required. Add correction factors if required. Next, the third one is calibration of the instrument according to the standards. Calibration of the instrument according to the standard. So these are the three methods which were used to reduce the systematic error. Next, after systematic error, we are going for in systematic error we have discussed about the instrumentation errors. Next, we are going for the environmental errors. So the second one in the systematic errors is environmental errors. So these environmental errors are caused due to changes in the environment. So the changes may be in the temperature, pressure, humidity, magnetic field or electrostatic field, anything may happen. So according to the changes in the temperature, the values which we get from the measurement or which we get from the instrument may change. So the reasons for the environmental errors are, it may be the changes in the temperature, pressure, next humidity, next electric field, next electrostatic field. So the value when taking the measurement may change according to the environment changes. So in order to avoid these environmental errors, so the methods which we use are, so the methods used to reduce environmental changes are, so the first one is we have to provide a condition to the circuit. So the first one is providing a condition. Second one is providing seals to all the components present in the instrument. Seals provided to all the components in the and the last third one is providing magnetic shields. Magnetic shields. So these are the environmental errors which may occur due to changes in the environment, which may be temperature, pressure, humidity or anything can be considered. It may be of a magnetic field or electrostatic field. So the methods to reduce this environmental error are, first one is the providing air conditioning and the second one is the providing seals to all the components in the instrument, and also the third one is the magnetic shield. So we have to keep the instrument safe and we have to prevent some dust. Then only this environmental error will be reduced. In the today's class, we have discussed about the types of errors. So the first one is the close error and the next one are the systematic errors. So in the systematic errors, we have completed about the environmental errors and also the instrumental errors. So in the next class, we will discuss about the observation